We're just gonna assume everything's fine, and that everything will come back. So we could try nudging stuff around. So if one of our corners, like if none of our corners are colliding, then there's only a few different situations for this. There is, like, you know, something is bisecting us, you know, in some way, or we've got something inside of us, like we are fully containing something. So something will either be, you know, penetrating one of our sides, or it's going to be within us. And I don't think there's a real good way to, like, we'll either know. All right, looks like the stream finally came back on. That was definitely Twitch, because I had internet. So it's not my fault. So let's keep working on this. So if none of our corners are colliding, then something's bisecting us. So what we could do is get like a vector between those things and try to nudge ourselves out by the vector in kind of a componentized fashion. So we could, you know, again, try to move ourselves up and then try to move ourselves left and things like that first. So if none of our corners are colliding, get a vector between the centers of the object we're colliding with, and nudge ourselves based on axes out of that object as such. So if we were penetrating like here, we're basically going to move ourselves up first. And if we were penetrating like so, and, you know, the center of the object is basically saying, well, you know, like the object is in this direction, we would need to like move ourselves down to nudge ourselves out of the object. And if we were in the case where, you know, this is us and we've got something inside of ourselves, we would again just be like, well, we're gonna move ourselves up and other stuff. So if something glitched, if we glitched so that, you know, something was inside of us, like we had a log or something, and Bitey suddenly freaked out and became 200 times the size of himself, he would jump up and out of it. Not really happy with all that. You know, it's almost like, it'd almost be like, you know, pull the plug on analog physics and just go to, you know, using tiles and things like that for physics objects. And, you know, build a grid out of the whole damn thing and just move on the grid. because then we could have a lot more constraints. I mean, a lot more guarantees as to what we're doing. Because if you're moving on a grid, you've got very specific grid types and chunks. But I don't really want to do that. Bitey being 2 units high or something. Everything's like that. And then I tell Adam to re-rig everything. And everyone cries horrible tears. So I don't really think so. I think we're going to just try to get this to work properly. Because I don't think we're going to have too many objects that actually cause us massive problems. And what we can always do is just ignore the problem. We can nudge ourselves out of things, and should be close enough. Should be good enough, right? That's not a problem. Alright, so let's go through our other cases here. So if we are stuck on a wall, so we are on this wall, and we are penetrating chunks, penetrating an object like the wall. Well, we're very quickly going to, one of our corners is going to be penetrating. We're going to move out of the wall based on that. And the question is so that would work. So all these little things would work there. And if we're in the air and all of a sudden we're penetrating something, it's kind of the same thing. We nudge ourselves out, we'll be outside the object. We should be good. So let's get on to the complicated cases. Let's say this is us, and we are stuck between 2 walls. What the hell are we going to do? So if we did this, basically we would have an array of hints that we're going to have. And we're going to test our points, and we're going to be like go from the bottom left, and I'll be like, alright, so we should move out, to the left, and that would mean that our square would move. Let's just draw our situation first. We would move our guy over to here, because we'd go by whichever one returns first. So we'd move our guy over to the right. And then what would happen is we'd be like, okay, we're now colliding. We would test again, and it would be like, no collisions here, but then we'd have collisions over here. So it'd be like, okay, cool, let's move our guy to the left. And we're like, okay, cool, let's test again. We're colliding again. Great. And we would have to, what the hell are we going to do with that? We could move it once. What would happen is the guy would be penetrating this wall, and then the next frame he'd be penetrating this wall. So you'd see your character literally just freak the hell out if you were between 2 objects that were right next to each other. Basically, your guy would just go straight to hell, and nothing would happen that's good. So we need to make sure that at least, I think, we get stuck into one of these objects, and we get stuck there consistently forever. So that this case right here would always result in, okay, we're penetrating the wall over on this side. We'd move our character, we'd try to move our character over to the left, and we'd say, well, we're now stuck on this other wall, so we can't move there. And as a result, we would just kind of stay stuck in the wall. And then what we need to do is when we do our sweep test, we would need to make sure that we don't get more stuck in a wall or something. So in this situation, let's say we're in a hole or something like this. Bitey's actually standing on the ground. He needs to be able to jump out of this hole what would we do? We need to allow him to move up. Well, basically what we do is we would say, okay, well, you can't penetrate this other thing any farther than you already have. But then we come into issues where, you know, if this has like a lip on it or something, and you just can't move. We just be like, you're stuck forever, you're dead. Rest in peace, Bitey. And you know, a big solution to these problems is just don't put two pieces of this crap right next to each other and you'll never run into this problem. Which is fine, except we got fucking logs where we at least have this situation. And we always need to make sure that if Bitey stands up, you know, if Bitey's vertical box collides with stuff, that we're pretty much, I think, just gonna, like, you get stuck, you can't move. We're not gonna move you, and instead, like, you can't like continue sliding. If we somehow get stuck like this, we don't let the player move. We instead, you know, do the zipping thing. We are going to move your character. Like, if we get stuck where we can't nudge you out in a cardinal direction, I think, yeah, we're gonna do the Super Mario thing. And we're going to move you. We're going to move you to the right until you're out of the object. We're not going to let you go down. You can't go down. That's bad. No going down. We're just going to move you to the right until you're clear of the obstacle. And we're going to always make sure that you can actually move out of it. So if we ever have a log, we're not going to have a log in a spot where there's like a spot where you'll get stuck. So if you kept going this direction and then you got stopped by another piece of geometry, like, okay, we can't sweep you over to the right whatsoever. Maybe there's something we could do here where we're like, okay, you're penetrating this object and there's nothing we can do about it. So we're just going to move you to, you know, in a direction. And when we get over to here, you know, you're going to be up against this wall and you're still going to be penetrating with like this corner. Or the log is like coming right in here. Anyway, how do we resolve this? If we're ignoring the sweep test against this object and we're moving the character ourselves, not allowing the player to do anything nuts, what would we do if we hit another piece of geometry? I mean, we could basically say like, okay, we're already moving this player to the right, and we've got to a situation where he can't move any farther to the right because we're encountered some geometry. We could just say to hell with it, we're moving him up. And then of course then the next question is, what if there's something right here that we run into? So, you know, we run into that. And we're like, okay, we're already trying to move to the right, and we can't move to the right anymore. And now we can't move up, so we're going to try to move you to the left. And then we... and it's going to keep moving you to the left until it can move you up again. And what's going to happen is, he's going to move over here to the corner of this thing. And, well, no, it's gonna stop working. We gotta, like, okay, you can no longer move right, so it's gonna just like, you cannot move right any farther. Okay, cool. So we're gonna go up. We're gonna run into this thing, and it's gonna be like, you can't move up anymore. So we're gonna be moving to the left, and if we move to the left, we're just gonna like go out of the fucking log on the other side where we came from, and then he'll drop down again. Um, and if we ran all the way to the left and we ran into something, then we're going to try to go down. And we would go down through the entire world and off into space. And you'd fall through the world, and you'd be in the molten core of Brackenwood, and you're toast. You're gone forever. There's nothing we can do about it. Well, I mean, this is just basic platforming for 2 dimensions, right? Like, we don't even have moving platforms. And doing this in an analog fashion. If we had, you know, guaranteed constraints, like, you will never have a character that, you know, is a half box wide. They're always a box wide, and there's all gaps are a box in, you know, width or height minimum. Then you can always have rules that are like, all right, well, this is valid collision, this is invalid collision, and that's how a lot of things solve it. Well, there's other things. The other thing is we could allow you to not penetrate an object any farther. That's a question. But of course, if your head goes through the object completely, then like you're just ignoring the collision with the object itself. Well, I think basically what we do is if we're nudging this character and we can't get them out, we just never nudge. A certain distance or something. We could be like, all right, well, we could probably just solve this where, you know, if we just followed these basic rules, if it got to we can't move anywhere, like we move you down, you know, we're gonna run into the frickin' floor right there, and then we're gonna have to. We just wouldn't move anymore, I think. And if we had multiple objects within objects, we'd be screwed. Well, if all else fails, let's just go read some fucking articles online. If you start looking at like, well, how does Sonic work? You know, it's like you're standing and then there's pushing and yeah, I see it's all just like, you know, grid-based physics and all that sort of stuff. So I mean, if you go into like real deep as to like what the hell all this crap actually does, You know, you're looking at all these different ways that you can actually move, and if it's all modeled in grid square space, then that whole thing. So that's another thing we could do for movement is instead of trying to actually move kind of as a physical object and move this object through the world and try to keep it out of stuff, we could kind of move based on heuristics and shit like that. And just be like, well, you know, there's a vector forward, we can go forward, and you know, it doesn't really matter if you're penetrating a wall or something else, because it'll just be like, oh, well, you can totally move. But that's with like that's if you actually even have tiles, you still have to deal with all that crap, you know. And there's only a set number of angles that they have in games like this, so we have to go deeper. So should we just make everything into a grid? The world is digital and not analog. Should we do it? Well, I don't want to. I'm not seeing a good solution, so unless there's some genius out there who's already done all this crap before and wants to tell me, come on, you moron, there's this mathematical theorem. It's called the separating 2D platform mathematical theorem. And you don't know about it, you didn't learn about it in college? Well, you're just a moron. You should know how to make things move. You call yourself an engineer, and you don't know anything. So let's see. So we've got our movement right. Like we're able to move through the world. That's great. The current problem is basically our collision geometry could change, and as a result of that collision geometry change, we could encounter a situation where we are now penetrating an object which we should not be inside of. So the question is really, is there a way that we can just never have this happen? Right? Legitimate question. All right, we got this big freaking problem. If we're stuck inside of something, we don't know how to get out of it. So is there some way we can always guarantee that we never get stuck inside of an object? So one way could be, so Bitey is, this is a log. Bitey is sliding through. And all of a sudden, Bitey stands up. Well, what we could do is we could basically just be like, hey, Bitey, you stood up, and the physics box, you're now colliding with crap. We are not going to let you have that physics box. We are going to say, no way in hell. You may be playing the animation where you are standing, but your collision box is going to remain this smaller collision box right here. And that's fine. So like Bitey stands up, and he can still walk outside of this thing until his, he can actually stand up. And at this point, Bitey is still standing, but now he can actually use his standing collision box. That's not a bad idea. So what would that look like? Basically, if we have totally fucked up Bitey's collision and he is facing to the right, and when he faces left, his ass goes through the wall. Basically, he would have his right-facing collision box, but he'd be looking to the left, and he'd be fine. He'd be right where he should be. And what would happen is, as soon as he moved his butt out of the wall, he would be outside of the wall, and there wouldn't be a problem. Solution: don't give Bitey a fat ass. So tell that to Adam next time you see him. And of course, if the collision boxes are perfectly symmetrical, as I'm telling Adam, at least make them symmetrical on that rotated around that z-axis. We shouldn't have butts getting stuck into walls or other things. So that shouldn't be too bad. But we still have the vertical issue. So if we try to switch to an animation which has a vertical issue, a vertical problem, we're going to use the previous things. So if we somehow had an animation that... What I'm really going to want to tell Adam is, well, this is kind of what we're already doing, is all the rigging things pretty much are just using like 1 or 2 boxes. And it's not a problem. So we could get into some interesting situations where you basically get like stuck into... You're using a smaller collision box than you normally would. And you might be able to do some really crazy shit with that, like, use Bitey's small collision box to get through something you shouldn't be able to get through. But I'm not actually against that sort of thing. Like, if somebody figures out some crazy way to like wedge themselves in a log and a mushroom, and all of a sudden they got Bitey's tiny hitbox, and then they can like sneak through something and get to the final boss, like, I don't care. Like, they freaking deserve it at that point. That's great. So we're just going to have it, if you get stuck in a wall, you can't move. And let's make sure you never get stuck in a wall. Or we could do something silly, like just do like a ray cast, see what the hell happens. Like, just kind of teleport your ass around the screen, find a good place for you to stand. You know, so at least you're not just like stuck and they'll crash. You know, kind of a soft lock in the game, as it would be. And I probably will just have to tell Adam, for Bitey at least, just stick with the simple hitbox, and you know, on the art side, we'll just stick with what we got. So, before changing our physics objects, we need to test the physics objects against the world. If we cannot change our physics object, we don't. So the other thing is, if Bitey has an animation where he where his collision changes, like he gets bigger during the animation, he wouldn't actually change if he was like right next to a wall. It would just keep his box small and just be like, no, nothing is changing. It's not going to be smart enough to basically be like, well, he can get bigger in this direction. No, it's just going to be like, no, you're not changing your collision. It's not really an issue though. And we do actually have control over the collision objects. And okay, so before we do our collision, we need to check. We will still check if we're penetrating any geometry. And why don't we go for like some super simple checks here, just to save Bitey in case, you know, our checks fail. Like, okay, we've got him. He is inside of this thing, and for some reason we've gotten into some sort of horrible mess. How should we save Bitey if he gets stuck? Like, he's stuck, and our movement is saying sweep test failure. Like, you're not moving, buddy. How should we fix it? Should we just like do something idiotic and just be like, alright, Bitey just moves up until he's out of collision? And we do this for anything. If anything gets completely fucked up, we start moving them up in the scene until they're outside of the collision area. And then basically what we always do is we have, like, if there's a ceiling or something, we just make sure that there's plenty of room, so, you know, you always teleport a little bit up and then you're down. Problem is if Bitey's in like a cave or something and there is nothing above him, so like, you know, if we're running through this cave and all of a sudden physics is fucked, then we move him up, and then like he goes into solid rock, and then Bitey like keeps going up until, like, you know, this is like the top of the cave, and Bitey gets on top of the cave and there's nothing here. It's just the dark void of nothingness. And Bitey looks up. And he's just like, holy shit. I have moved into solid rock and I am gone forever. Reload the level, buddy. Reload the level at that point. So we'll need to just be careful in places like that where we don't have a cave. So if we actually have collision with the overlap test, we are going to just be stupid. We're going to nudge our character in the positive z-axis. Actually, we're going to do a couple things. It's basically going to be like do a couple basic things, like test if we can move in, cardinal directions up to a certain point, and if like we can't just like, tunk out of a wall, we're gonna do a few of those, and if all those fail, we're just gonna be like, well, fuck it, and just keep moving them in the z-axis, and if he's completely screwed after that, we make a better level. So this also means we're not scaling Bitey dynamically as he's running around, which we aren't anyway. So those are our rules. Basically, we're going to say you can never penetrate anything. Great. But alright, so we basically got our basic idea of what we're going to do. Why don't we just go read a few things here real quick. So this is just, I don't know what any of these articles are. I'm just going to, if you run into something, alright, we have a solution that we understand. Let's see if there's a better solution out there just by reading a few things. And now that we've thought about it, maybe we'll understand these things better, because when you don't know an answer, just Google it. We have the collective knowledge of the entire world at our fingertips. Let's use it. So how did this guy do it? The player jumps and he's got sensors, and he So this guy is moving with sensors, so you see if you're actually like gonna run into something. It's not super complete. Alright, well, I'm not finding anything super great. If anybody out there that you know of has got a better plan, then maybe I can look at it. But the best way to learn how to do anything in life is to go ahead and do it, and to completely fuck up every aspect of it until you're really good at it. Like, I'm not afraid of the guy who's practiced 1,000 different kicks one time. I am afraid of the guy who has practiced one kick 1,000 times. So what we're gonna do is we're gonna practice kicking that one kick 1,000 times, and it's gonna be a kick straight to our own faces. So let's figure out how to move this bastard. Why don't we do it? So right now, we also have the ideal, like, with our, we do not, before simulated, yeah, before we change our, yeah. Yeah, this one right here. Before changing our physics objects, we need to test against the output. We cannot change our physics object, we won't. Right now, I have rigged up Fat Sack. We'll take a quick look at him. Come on, Fat Sack, let's get out of here. Say hello to people. So there's our test level. We've got Fat Sack right here. And if we take a look at this physics object, this object is not changing on any frame, and it's not changing for any animation. So basically, he's a box, which is fine. So we don't have any of those crazy edge cases where we have to go double check and not change our physics object if changing our physics object puts us in an undefined and unusable state in the world. So we don't have to do this first part to begin with. We can do that later. So we can actually just start implementing stuff. So we're going to start with implementing the moving through the air and moving along the ground states. And I'm going to try to write this down. Alright, so we've figured out how we're going to actually implement a few of these things. So now we're going to start writing it. So we're going to, I have a little notes over on the left, which I like to organize my thoughts with. So write the on-ground movement. Write the in-air movement. So right now we're going to do the on-ground movement, and we're going to do the on-ground movement first because we're just going to assume we're always stuck on the ground and we can't jump or do anything because we're crippled. So let's write our crippled movement controller. We broke Fat Sack's legs, so he can only move left and right, but he can't jump. So how do we do this? So we need to get some information, don't we? So we need to get set up as well. Dashkin movement object. Where is that movement object? There we go. Movement object. So we got the directions, movement types, physics, flying, locomotion, movement state, flying, sliding, stationary, moving, rising, air, stationary, and falling. Okay, yeah. He's durable. Fat Sack's taking a beating. This isn't the first time he's gotten knocked around. So we're going to have Dashkin physics. Do we have a physics state? I don't see a physics state, so that's what we're gonna create here real quick. And that's gonna be like, let me call it PS none. I'm gonna do all these things. So PS none is gonna be before the PS1. It's gonna be that we're gonna have PS on ground. We're gonna have PS in air. And we're also gonna have PS on wall. So on wall. So, excellent. We got our physics state, and let's actually put it on our object. And we're gonna kind of segregate these things again. Kind of abusing a few mechanics of C++ to segregate a few variables. So we'll just get a getter for that guy. And a setter for it, why not? Screw it. We don't want anybody setting it though, so we'll just have a getter for it. Again, we'll hide our getters in the bottom of the file because we never want anybody looking at this code ever. Ever. Excellent. So what we need to do is we're going to be moving this in increments. So I'm going to compile this real quick and throw a breakpoint here. I want to see exactly what we're getting back with delta t. I need to know what it is, because we're going to need to move in physical chunks, like we were talking about earlier. Basically, we want to break up the frame time into a unit of time that we simulate our movement for, and then a little extra. And that's how we'll move our object. I just need to know if this is like 17 or if it's 0.016 or whatever the hell it is for like the 17 milliseconds of our 60 frames per second. I should really learn how to like drink liquids like water and soda without like choking on it. Like you would have thought I would have learned how to do that by now. I haven't. Sometimes I wonder how I'm still alive. I'm kind of liking streaming coding. Mainly, it keeps me from like. I actually have to like stay on task and shit like that. It's kind of nuts. So for our delta t, oh come on, give me a delta t here. We don't have it. We don't have a delta t. Well, let's go up a function and see if we got it. Nope, totally optimized out of there, isn't it? Oh, there's one way to get the delta t. Let's print it the frick out. I hate it when it hides this crap from us. Movement object. Yeah, the big thing is like, since I'm working on my own hours here in my basement by myself, you don't have the structure of working at like a big company where you got, okay, we got our 10 a.m. meeting that we all go to, and then, we all go to lunch, and then, we come back from lunch, and then we have like a 1:30 meeting with another group, and then we have sprint planning at 3 o'clock. All this other bullshit that you do in like, the real world. It actually helps you like structure your day. So let's see, updating. So it's basically saying that our DT is 0.00833. So this is looking like it's in seconds. So what do we want our step to be in seconds? So, 60. So 60 frames per second would be taking 0.06. So we'll just throw it on there. Basically, what we're working with right now is, this is what we're running with. This is what is going to be 1 frame. So if we made our step basically 5 milliseconds, we would have 3.005 steps, and then we'd have 1.0016 or be like a 0.14 whatever the hell step at the end there. Yeah, 1.6. Anyway, so it looks like that should be our physics step time is 0.005. So let's go throw it up there. So there's that. And in our movement object, basically what we're going to do is, in the top of our update, we're going to basically call our update with a frame time. So we're going to need to separate this out. So it's going to be and we should probably tick this with the time that is left. So like what we're going to do is we're going to call tick movement with delta t. We already have a move object. Yeah, move object is just simple. Alright. Move object is just that simple hacky move object method. And what tick movement's going to do is, perhaps we should return how much time is left to move. So we would do something like, we do like a do and we do like while like delta t, float remaining dt equals delta t, and we do like while remaining dt is greater than 0, we're going to set remaining dt equals tick movement remaining dt. And what we're going to do with that is basically we would say, okay, cool, let's return, let's say our float is going to be float physics step, and we'll set our physics step equal to that global global physics step. And we'll say, well, if physics step is, if delta t is less than physics step, then physics step equals delta t. So it's always going to be the current remaining stuff. And we're going to return how much time we simulated. So it's going to return physics step. And of course, what's going to happen here is we may actually return a different step than, like, we may actually only simulate like point, 0.001 instead of 0.005. So physics step may change with this guy. So we'll just actually return these guys, and this guy's just gonna. We want to actually return something else, don't we? We actually want to return delta t minus physics step. That's what we want. And for this guy, we want to make sure that the remaining dt is, it's not just greater than 0, but we want to like do something, we're not going to simulate any less time than, like 100th of a millisecond or something, if we don't have time. And let's also throw in like a little counter here, just while we're working on this. Let's just throw some sanity in there. Warn log exceeded max physics iterations for object. And we're just going to break out the loop. So I'll have the G physics step time and G physics min sim time. And that's the minimum amount of time that we'll actually simulate, otherwise we're just going to throw that time in the trash can, because we can be pretty harsh on time. Not a problem. We'll eventually get these things moving around. Eventually. So we got our counter. So all of our update functions here are going to need to return how much time they simulated. They're returning